Hey everyone, thank you all so much for joining. Really excited for this webinar. We're going to give it a minute to let some more people roll in. It was really exciting putting this webinar together. There's been some things in the news recently, a recent article proclaiming that decarbonization is dead. We can see very clearly from the interest, even just in the built environment, in this webinar, that this is very much not the case. Upwards of like towards 200 registrants for this. And it's really exciting to gather together this list of panelists and all of you attendees to discuss decarbonization of the built environment. As people are trickling in, there's a chat function. You can look at an audience chat. I see people already starting to jump in. Thank you. Margot says the audio is pretty echoey. I'm sorry about that, Margot. It might be my microphone setup. I can try to work on that. If there's other people here that want to sort of announce themselves in the chat, I see Kira from Kansas City. That's Kira Gold for the people that don't know. A great in the world of green building. Stu from Branch Pattern. Hey, Stu, thanks for being here. Awesome. I think we are probably just about at quorum here, so we can start kicking off. Hey, Julia. Hey, Susanna. Ryan. Ryan Welch, one of the masterminds behind Tally. Great to see you. Jesse from Brightworks. Rami Ayaso from Austin. Wow, really amazing group of people here. Thank you all for rolling in. Okay, so with this, oh my gosh, I'm just loving the chat too much. I have to close it or I'll keep getting distracted. All these great people. So we're really here today to describe what we're calling climate action's connective tissue. The data that connects supply chain to product to building decarbonization, and how by coordinating across these value chains, which are sometimes big, complex, and messy, we can knit together the decarbonization of our built environment and the decarbonization of the industries and supply chains that support it. There's a report that the Carbon Leadership Forum did a few years ago that is often a reference for us in this work that really lays out the vision of a connected data ecosystem. And as part of that, they did these mind maps of the current LCA data ecosystem. And you can tell just by squinting at this that the current LCA data ecosystem is sprawling, complex, and poorly connected. But the point of this webinar and everybody who's here speaking to you today is really united in one vision that it doesn't have to be this way. That it is possible that we create systems in the industry that take supply chain data from material producers, roll that into actionable, transparent EPDs, use that to do project level whole life carbon assessments that drive low carbon buildings and cities. As material supply flows from producers into buildings and cities, it has the counteraction of structuring demand signals for low carbon materials and moving those back up the value chain. These sort of four, we'll say like steps in this process illustrated here are represented by the four panelists that I'm really excited to share this webinar with. I'll give brief introductions before diving in. We have Ben Christensen, the CEO and co-founder of Cambium, the supply chain technology pioneering robust digital infrastructures for urban wood waste. Alex Cooper, the co-CEO and co-founder of Pathways, AI-enabled platform to accelerate material decarbonization through product lifecycle assessments and EPDs. Rebecca Reese, the performance director at OPN Architects, and myself at C-Scale, leading whole life carbon assessments for buildings. So over the course of our presentations, we'll walk you through that data landscape and how by connecting product and building decarbonization, we can not only create a healthier and lower carbon built environment, but also de-risk important parts of both the material procurement and construction processes. With that, like understanding that there's a lot of stakeholders present on stage, we imagine there's also lots of different folks represented in the audience. And the first poll we'd like to run is, who are you and where do you come from? What part of this value chain do you represent? Seeing some votes rolling in. As these votes roll in, I'm going to take another look at the chat. Awesome. Lots of votes coming in. This is really great. And it really speaks to, I think, especially C-Scale as the convener here, our audience is really people in AEC, architecture, engineering, construction, but also obviously pulling people in from across the value chain. So with this, I think this is interesting information probably to all the panelists as well. I'll step back and I'll pass the stage over to Cambium. Ben, thank you so much for participating in this webinar.
Thanks so much, Jack. Really excited to be here and excited to talk more about Cambium and excited to dive in here. To talk a little bit more about Cambium, we are a company of just about 50 folks working to address the low carbon industry and bringing building materials to market. We do that by building modern supply chains for the wood industry. So I grew up in forestry, was born and raised in a town of 200 folks. And whenever folks think about, sort of wasted material, I think we think small. And one of the big things that we are really trying to share with everybody today is the waste problem for, wood is really actually very, very big. And, when you bring it forward in a way that really brings technology into the process, we can create a new model for bringing materials into the built environment in a big way. So first, a little bit more about the problem. So in the US alone, there's about 110 million tons of wood waste that come down every single year. That's wood from cities. It's from our expanding urban environments when we build new buildings. It's material that comes down in disasters. It's the material we're pulling out of Western forests to address fire suppression. So there's this huge, huge, huge volume of wasted material. In cities alone, there's about 36 million trees that fall every year. So again, these are trees that are, exist in forests that aren't managed. And so the perspective I'm really trying to bring to this webinar and this perspective is really at the material level, and then we'll get into the data level sort of next. So first, thinking about these trees that are on streets or in Central Park or in riparian corridors, that when they get old or they get storm damaged, those trees are going to end up, really having a sort of end use that we really don't want. Currently, we spend almost $1 billion every single year paying to dispose of trees in landfills. And also, we spend a lot of money mulching trees. And so when you take a big solid piece of wood and you cut it into little tiny pieces to let it off gas really quickly, it's not great for climate. And there's a much better way to engage on that. And today, there's about 90% of material that comes down is currently being wasted. So there's this huge volume of material that right now exists out there, but is really disaggregated, it's fragmented, and it's not being reused at any significant scale. So the scale of this problem is really, really big. Our whole mission is to transform the system where you're taking, all of that fallen lumber. And if you looked at the sort of upper end scale, that's about $40 billion in usable lumber every single year. So it's a really, really big opportunity, which is almost 3.5x more than all of the wood we imported as a country last year. And so if we can start using that material at volume, if we can do that in a way that meets cost and data and transparency concerns, we can then really be replacing a system in a much, much better way. So we at Cambium really are building a solution there that's focused on really developing modern supply chains for the built environment, using technology to simplify sourcing, improve pricing, and deliver better outcomes for people on the planet. So the way that we think about it, and this is sort of our theory of change, and this is how we particularly fit into this conversation, is if you can bring better materials to market that are lower carbon, better for people, better for communities, and you can really drive and have data that surrounds those materials, you're going to enable the scaling of those materials in much bigger ways. So what we really focus on is providing software upstream at all of the different steps along the wood value chain. When a tree falls, when it gets moved on a truck, when it goes to a sawmill, when it goes to a drying center, and capturing that data so that we can work with amazing partners like the other folks on this call to really translate that data into environmental impact. But I think one of the big differences that we see as a company versus pretty much every material supplier out there, we see supply chain data as part of our responsibility to really bring that forward into the built environment and then really bring best-in-class science to analyze that data. So when we source this material, we are really providing material for sort of three big categories. We're doing this today at national scale, but into millwork. So looking at indoor and outdoor applications, we have lots and lots of different examples with tons of different buildings there. We've really scaled into mass timber in some big ways, bringing the first reclaimed mass timber panels across the country. And then furniture, we have a number of partners where we're providing primarily hardwoods into furniture use cases there. We call our material carbon smart wood. And so if you are looking to source it or use it, carbon smart wood is material that comes down naturally. It was not felled for harvest, and that provides full data transparency. And so that's one of the key sort of components of carbon smart wood, is that you can actually see where that material came from. We are big believers in certification as an effective mechanism. We also see its limits and really see the future of environmental validation around being able to translate and have full data transparency on sort of the whole supply chain. So we do that by providing software at all of these different steps, so that when wood moves from new tree to fallen tree to sawmill to manufacturing into the end customer, that the end customer is able to really see where that material came from. And you can see that at the board level. We're not fully there in every single use case today. We're continuing to really grow in that space and to provide that data through our supply chain technology. It's been really exciting. And as sort of Jack mentioned, there's tons of buy-in on this process overall. Lots of different large brands who are sourcing this, and kind of to that initial question of what are the barriers, we really see that it's our job to bring product to market that has better data, but also in particular has better pricing, has a much better purchasing experience, and then also is providing that better impact. So we strive to do that in every single use case and are starting to do that in bigger ways across the country. One of the amazing things about having a data-driven platform is that you can cut out wasted steps. So when you produce a material like a commodity, you are not doing sort of N of one supply chains. And when you know the end use, when you are starting, you're able to cut out some of those initial steps. You can reduce your inventory costs. You can reduce the amount of time that wood needs to sit in a warehouse. And all of that helps reduce costs for the end customer. And it also often reduces logistics steps, which lowers the carbon footprint overall. We're also really focused and see this as a key part of the conversation here on improving the experience. So when somebody purchases carbon smart wood, being able to really deliver a simplified, real-time tracking of that material, data tracking of the implications of that material, and then also some key project management. Today, when you purchase wood, you don't go at any of these tools, and being able to do that at scale and consistently is huge. And then the last piece is really being able to deliver better impact. So our material is much lower carbon, than traditionally sourced harvested material or a bunch of the sort of recycled plastic alternatives that we're often competing with in outdoor use cases. And so there's a much bigger opportunity to really scale that impact overall. We are huge believers that, sustainability starts with stronger supply chains, and that as material companies, the more that we can couple the financial asset, so that transaction between somebody with a tree to a trucker to a sawmill to, a manufacturer. If you can participate in that, if we can participate in that, we can provide dynamic data for the end customer that ultimately delivers better pricing, better impact, and a better experience. So that's what we're all about, and really excited to continue the conversation today.
Ben, thanks so much for sharing that. Before I dive into Pathways, it's just as I'm reflecting on it, and I'll share with folks in a second a bit about what Pathways does. But I think one of the things that I'm impressed by, and that we see as well, is that with better data, users don't have to necessarily see a trade-off between sustainability and cost. In fact, sometimes those things can go hand in hand. And I'm curious, whether within your own operations or with the customers that you've worked with, if you've have just some examples you can share of how having that deeper understanding of supply chains and greater visibility into like what you're actually using has changed behavior, either to drive sustainability goals and or to drive economic goals?
Yeah, it's a great question. And, today, as I mentioned, we're really supplying material into mass timber buildings, that are building, data centers and these large sort of warehouses. We're supplying material for millwork, that's going into lots of different, architect-centric projects, and then really into furniture companies. And one of the great examples of, when you actually understand the supply chain, and in particular, when somebody who is specifying material in a project or in a product can tell that story to the rest of the decision-making group that is deciding what material to use, they're able to see and understand, one, pricing implications in a much bigger way. We are huge believers that better price is one of the biggest drivers. And then also a sort of larger impact if you did this at scale. So I think one of the big things that we really see that data can help communicate is that often we can be a little myopic. We're thinking just about one, immediate project or one immediate product. It's like, hey, if we actually zoom out and we look at this at scale over our next 10 builds or our next 10 installs, there's a much bigger impact here. And, at scale, those things are much bigger. So there's tons of opportunities to really scale that. A great example is, drying is a very intense step in the process, and something like mass timber needs to be dried to a lower, moisture content than sort of traditional material. And so by, actually doing that on the front end, you can skip an extra drying step at the mass timber manufacturer, and that then provides cost savings. So those are the kind of, extra steps that, again, having the data overall allows you to skip and be more efficient in the supply chain on.
Cool. No, you scooped my second question on how you're using some of those that data-based environmental information to drive operations and to drive growth. Awesome. Well, thanks for sharing all that. I'm I guess excited to transition over to a bit of an overview of Pathways. Okay. Hi, folks. My name's Alex. I am one of the co-founders of Pathways, and we are building a data layer for manufacturers like to be able to drive sustainability and to really support sustainable manufacturing. So what are we doing at Pathways? Well, we're really focusing on building out technologies and platforms. We call ourselves, we have AI in our name. The thinking around that is, how are we using technologies to systematize data collection and just make it much easier to build and maintain these life cycle assessment models to both meet evolving regulations, but also to really drive decision making and really use this not just as a check the box exercise, but really as a tool that can help further reduce the environmental impact of the products that our customers are manufacturing, and then help them win business based on that sustainability. And so really towards that goal, think of ourselves as being that end-to-end sustainability data platform, both serving a role of mapping and working through the different data that exists across our customers' production and operational systems, and then using that to create third-party verified independent environmental product declarations. And so that's really where we see ourselves coming in. We work with these material manufacturers to help them often the focus is getting faster EPDs and making it take less time and less effort. Environmental product declarations, 10 years ago, were very much an academic tool, an academic document. They've now become a foundational tool that decision makers across the building and manufacturing ecosystem rely on to make decisions and to accomplish sustainability goals. But because they come from that historically academic approach, they've often been difficult to actually accomplish or iterate on at scale. And so that's really where our core innovation has been. And so what do we do? Well, we've built a number of different technologies to just make it a lot easier to gather all of that data and then to allow users to see it on an ongoing basis. LCAs and EPDs are often snapshots in time, but manufacturing processes are continuing on an ongoing basis. And so what we're doing is supporting our customers so that they can see how the footprint of their product is evolving as they make different business and operational decisions, as they make decisions about who's in their supply chain, or make efforts to decarbonize their own or reduce the environmental impact of their own production processes. And then we work with third-party program operators and independent verifiers to take that analyses and help our customers turn those into those environmental product declarations and more customized sales assets so that our customers can use those sustainability accomplishments to drive business. Just doing a high-level overview. Some of the folks here are on this call today, but this view of where do material and product level EPDs live, and sort of where is that within this ecosystem of sustainability of the built world. And so this is sort of where we see ourselves play. We're working directly with material manufacturers on that material level, and then we're pushing that information to decision makers throughout the building and manufacturing spaces so they can use that to drive sustainability outcomes. Just as a high-level overview, so what actually is a life cycle assessment? A life cycle assessment is looking at the total environmental footprint of a product. It can go from what's called cradle to grave, so from the extraction of the raw materials when they're first produced through their disposal. But in North America, generally what they focus on is something called cradle to gate. So basically everything that occurs in your supply chain through when a product leaves your facility. And so that's really where the focus is as we think about building these on real-time LCA models. This is the part of the manufacture of the process that manufacturers have the most control over, where they're sourcing their materials and what their own production processes are. There are some, of course, choices that they can make about how those products are then used and disposed of later on in their life, but it leaves the manufacturer's control. And so that's where the A1 to A3 or cradle to gate impact comes from. And so that's where most of our focus is. And so we do a couple of different things. We integrate directly with production and procurement and operational data systems to gather this information. And then we work with unstructured data as well. That often comes in a variety of different forms. And that's sort of one of the core innovations that we've brought at Pathways, is how can we take all this information, which often already lives within our customers' ongoing production and operational processes, and just make it easier to pull it all together and structure it in a way that they can engage with and think about. And so, as you might be unsurprised to learn, a lot of times this can be involving bringing a lot of unstructured data and putting quite a bit of structure around it. Historically, this work has been, the burden of all this has been put on the manufacturers. And so they might work with an LCA expert or some sort of third party to create that one-time point-in-time environmental product declaration, but all of the work was put on the operators. And so even if they were finding these EPDs, even when people find EPDs to be valuable, and I was heartened to see at the beginning of this call that people saw that they did have value, when it's so difficult to go and gather all the data to publish those EPDs, they become deprioritized. It's just too much effort. And so again, that core focus of ours has been how do we go and take all of the data that exists and then model it in a way that both helps our customers publish EPDs and make decisions. Just a little more detail into the different types of data systems that we integrate with, and how these different integrations can come together. But really, at its core, what we're focused on is making things simple, making them fast, and making it so that our customers are able to go and actually create the EPDs that they need to drive decision and win new business. So that's really what our focus is on building that data layer and then empowering manufacturers to use the data from the data layer to communicate about their products and drive sustainability in business.
Thanks, Alex. It's really exciting to see just how quickly producers would be able to generate EPDs, and that would be an easier process for them. I think this could really be a game changer for us in the architecture industry to be able to ask for information during the design phase and then potentially actually get it during the design phase when we can use it to help make those better, more informed decisions. So thank you for sharing that. I'd be curious to hear, based on your experience, what are the main reasons that manufacturers are choosing to develop EPDs, and how can architects and engineers and the building industry help encourage more EPD development from them?
Yeah, it's interesting. There is a sort of virtuous and or vicious cycle element to it, which is if manufacturers have them, then it's easier for the AEC industry to request them, which builds the demand and it builds the case for manufacturers. But very clearly, manufacturers respond to market forces, and so when they know that having this information available, and not just having it available, but actually reducing the footprint of the materials that they're producing are going to help them win additional business or maybe even charge a premium for those products, then they're very motivated to do that. And so where we've seen the broadest amount of EPD adoption has been in industries or materials like concrete, where in order to bid on projects at the state or local level, concrete producers are required to have EPDs for those mixes. But as we think about what can really drive that, and how can we make it easier? I mean, our goal, of course, is to make it so that we remove the operational burden, so that hey, this is too much work to accomplish, so it's not even worth the premium. That piece gets removed from the conversation. But helping producers see how this can help them sell more product is, I think, really going to be the key piece. And obviously that makes sense, but to the extent that it can be specified or encouraged, not just in the design phase, but actually in the procurement phase by the general contractors or whoever's making the material purchasing decisions, that's, I think, where we'll start to see real broader adoption.
Thank you.
Thank you.
Hi, everyone. So I'm Rebecca Riss with OPN Architects. So the first step in this process before we can do anything meaningful with the data, we need to find the data. So we use two main types of resources to find product data: various online platforms that compile information from multiple manufacturers, and also going to manufacturer-specific resources like their online websites or contacting our reps. And I'll touch on a few of these resources in more detail. First, to understand embodied carbon baselines and the general availability of embodied carbon data for various product types, I frequently reference the material baseline report developed by the Carbon Leadership Forum. CLF published an update to this report just last month, which I highly recommend checking out. We also frequent Building Transparency's EC3 site to find environmental product declarations and sort products by embodied carbon intensity. And I find Sustainable Minds as a helpful resource to see embodied carbon performance alongside material ingredient performance. But there are many resources out there, and I'd say use what works best for you. When thinking about how I'm going to use product data, I find it helpful to put the data into context by asking how much data is available for this product type overall, and is there limited data available where I should just be asking for more information? Is industry-wide data available where maybe that next step is to ask for more product-specific information? Or is there plenty of product-specific data available already from a wide range of manufacturers? So I'll be walking through a few examples of how we have established product criteria, starting with CMU. There's a range of embodied carbon criteria that we can set for a product being used on our projects, ranging from disclosure criteria, where we require third-party EPDs of various types, to optimization criteria, where we set limits on global warming potential. And back in 2023, there was no industry-wide US data for CMU, so no clear US baseline. And in general, few CMU products had product-specific EPDs. And given the level of available data, we were able to explore requirements for product-specific EPDs on projects with clients that had low embodied carbon goals that were willing to maybe take that additional cost premium associated with being more restrictive on what CMU they were sourcing. But it was difficult to make a product-specific EPD for CMU baseline criteria across our projects. now in 2025, more data is available. So last year, the Concrete Masonry and Hardscapes Association developed an industry-wide EPD for US CMU. And as a result of this, the CLF has established a GWP baseline for CMU, and we have the ability to set more informed GWP limits on projects as an option for optimization. And also with this change in data availability, we're also exploring the potential to require product-specific or industry-wide EPDs as a baseline expectation for more projects. So I see this as an important way to give that positive feedback to manufacturers who participated in the recent industry-wide EPD, while also encouraging other local CMU manufacturers to develop EPDs. There is still, though, a bit of a barrier to setting GWP limits on CMU for many of our projects. We're located in the Midwest, and you can see that there are a lot of product-specific EPDs on the West Coast and the Northeast of the United States, but limited product data for much of the South and Midwest. So given that CMU is often sourced locally, we need to see more manufacturers in these EPD deserts developing product-specific EPDs. And to Alex's point before, I think that's where us asking and pushing for that criteria is going to be important. Here's another example for polyiso insulation. So for polyiso, we're trying not only optimize for embodied carbon, but also for material health. And currently with polyiso used in wall applications, we have an industry-wide EPD available, but hardly any product-specific EPDs. So there's slightly more data available on the material health side, though, with HPDs being fairly common. And so right now, with the data available, we can comfortably specify polyiso that eliminates halogenated flame retardants and has those HPDs disclosing material ingredients. We can also request industry-wide EPDs as a baseline expectation across projects, but we're having trouble really optimizing our polyiso product selections for reduced embodied carbon. And that's because of the current data barrier where we don't have enough product-specific EPDs for polyiso wall insulation to really be able to integrate that as a product requirement on our projects. And then the final example for products that I wanted to share is carpet tile. So thankfully, there's a lot of data available on carpet tile across multiple product lines and numerous manufacturers. And this higher level of data availability enables us to eliminate specific chemical hazards of concern like PFAS from our carpet tiles, while also setting low GWP limits well below the industry baseline. So once we've established the criteria we're going to set for various product types, factoring in the type of data available, we then need to integrate those requirements into the project specifications. And this is a critical step in the design process. Thankfully, though, there are multiple resources and examples available on the Carbon Leadership Forum and the Building Transparency websites. So at OPN Architects, we've been refining our specifications to include embodied carbon limits and restricted ingredients, and found these particular resources to be a great starting point. I also encourage teams to include these performance criteria as baseline expectations on projects, regardless of whether the project is pursuing a sustainability certification. Now, stepping back and going up a level, all of this product data also drives decisions at an assembly level. There are a couple of ways we typically use data at the assembly level. Early on, when weighing pros and cons of different assembly options, it's helpful to compare example assemblies. One great resource for this is Payette's Kaleidoscope tool. We can also analyze our proposed design assemblies using a range of tools that vary in complexity, including C-Scale, a Feather tool, and other life cycle analysis software. And here's just one example of how we have tested optimizations at the component level for an exterior brick and metal stud wall using WRNS's Feather tool. We're able to quickly understand the drivers of embodied carbon in the wall assembly and study the carbon impact of different insulation strategies and stud wall configurations. So in this example case, we can propose an option with a 14% reduction in global warming potential. And then outside of the tool, we can also test product-specific optimizations that further reduce embodied carbon, in this case by 20%. Here we studied lower carbon options that used product-specific EPDs for cold-formed steel framing as well as gypsum. But given the lack of product-specific EPDs for brick and polyiso, it's been difficult for us to optimize these products at that product level for embodied carbon, which is especially unfortunate here since you can see for this particular wall assembly, those two are the largest contributors to embodied carbon. So I hope this just helps highlight why it's so valuable to advocate and ask for more product-specific EPDs so that we can continue moving the needle on these products that are lacking some data. And finally, product data helps inform our design decisions at the building level as well. So a great resource to help put your carbon reductions into context is the Carbon Leadership Forum's whole building LCA benchmark study. And we also have the ability to analyze the embodied carbon of our proposed building designs in various tools such as C-scale and life cycle analysis software. All of these building level resources depend on a robust set of product level data to feed into them. And these building level tools are also extremely helpful for us to put carbon reductions into context and emphasize opportunities for further reductions. So with that, Jack, I'll pass it off to you.
Thanks, Rebecca. Really cool to see the work happening at OPN in whatever small way we can, try to support it. When I think about a firm like OPN, you know, you're one person at a much larger firm. There's obviously a lot of expertise in you in these topics. How do you in your work scale this practice and this expertise laterally across the firm to make sure that this happens not just on projects where you can dedicate 20 hours a week, but on all the other projects as well?
Yeah, it's I think a challenge that a lot of people in my role at architecture firms deal with. And I've found success in focusing on a few projects at first to develop a process and workflow that works for our project team that we're all comfortable with, and being open to adjusting that process based on their feedback. It's also been important to get project team members engaged and encourage them to take ownership on specific initiatives. As you mentioned, I can't be on all projects at once. So by having team members develop the skill set to comfortably lead that on a project and then take it to their next project is valuable. And we also try to communicate the project successes along the way to spread lessons learned from project teams and build more awareness and interest, so that as we start with a few projects, we can then scale those practices up to more projects across the firm. And I'll just also add that I've found it helpful to develop firm-wide resources as well, and trainings that can make it easier and more approachable for these low carbon design efforts to be rolled out at scale.
Awesome, thank you. Well, maybe I'll take that as a transition into the work that we're doing at C-Scale. One of our major kind of focuses as a company is to scale the practice of whole life decarbonization across the industry, to get more firms involved, and at the firms we work with, to get more projects, right, moving through a whole life carbon reduction process. We have been around in different ways for a few years, but really an independent entity building C-Scale since January of this year. And in the last 6 to 7 months, our sort of enterprise customers, the range of firms we're going to have modeled over 900 projects representing almost 100 million square feet of construction. We're incredibly proud of this, to be supporting so many projects in their sort of decarbonization journey, and are really looking to continue as we grow as a company to scale our support, do more detailed analysis to move these projects forward. But really, so much of the work we do is thinking on the margins. what's going to get the next designer on board? What's going to get the next project that wouldn't otherwise be able to do this analysis, right? To be able to do something, to go from 0 to 1, and then we can scale from there. With this too, of all these projects coming through, over almost half of them have set explicit emission reduction targets. And this, again, like the goal is not just to do the measurement of the emissions, the goal is to do something about them. And we're looking to build C-Scale into the sort of concept to construction platform to plan and execute whole life carbon emissions. There's obviously all sorts of stakeholders involved in the delivery of the building. There's a few reasons why we're really excited to work with architects. One statistic that always sticks with me from ThinkLab is that designers, people making specific choices on specific projects, have a purchasing power up to 2 orders of magnitude more than an average consumer. So, you know, we all go through our life, we make our choices, we choose to eat in this fashion or that fashion, we transport ourselves around the city using a bike or a car or a bus or whatever that is, right? But the decisions we make professionally have, you know, impacts that are orders of magnitude larger than our personal choices. And I really feel like this is something that designers take seriously, and we want to enable them and build tools for them to act on their desire to, you know, ensure their projects are contributing to a better, healthier, and safer world. The decisions that architects and designers make literally move mountains, right? These supply chains, like the ones that Pathways collects all that gnarly data on, are global and sprawling and have hidden environmental impacts. And on the other side of this, these same decisions, right, have the ability to contribute to regenerative outcomes, both in the built environment where the projects are happening and crucially upstream, and these, you know, often far-flung landscapes where these materials are sourced. How do we tell the difference, though, between the worst and the best choices? I think different people have said this in different ways, but this to us is the power of whole life carbon assessments, the ability to bring together building data on the processes that shape the building with supply chain data on the processes that shape the building's materials into a holistic view of the whole process so that designers can target decisions that matter most and make sure that the limited resources and time, as Rebecca mentioned, of design teams is really allocated in solving the most important problems. So when we think about whole life carbon assessment, just to give it sort of a definition, is, oh, a word fell off, so sorry, is a holistic description of the environmental impact of the processes and materials utilized over the building's lifetime is the missing word, but trying to look at processes and materials together to understand this building. Now, the goal of tools like C-Scale is to support this by giving designers the right data at the right time to support the right decision. Early in the process, this is identifying hotspots and setting goals. Then you add a little more resolution, determining schemes and systems. You continue to refine the model, get into assembly, start to look at materials. And then at the end of this process, you're working to procure materials. To build meaningful tools that target not just reporting and compliance, but also real reductions across the design process. The goal of C-Scale is to get started as early as possible in this and really shape the way that the project comes together. So we're not the only ones thinking about the sort of like LCA process in this light. One firm that we have sort of honor of working with is KPMB in Canada. They published this amazing document classifying LCA at different levels of resolution across the process. I'm presenting right now, so I can't find the link, but maybe if somebody has the link to this report, they can put it in there. It's really been an inspiration for us. And I think there's a lot of actually leadership on this topic coming out of the firms that we work with and other firms as well. And we're just there to sort of like scale those approaches, these good ideas that come out of practice, and make them more accessible to more people. Now, this understanding, though, of whole life carbon assessments in buildings, having to operate at these different levels of resolutions, sort of upsets this simplistic idea that has sort of grown up around the industry about the way that LCA happens, which is that whole life carbon assessments is just BIM plus EPDs. We have sort of different, you know, ways that like this understanding is disseminated through the industry, but there's a lot more happening than just BIM data and EPDs. You know, one important factor is that by the time BIM data is available, it's often a little too late. The big decisions are made, you know, the major pieces are in place. How do we get started a little sooner? And EPDs are really good at describing specific materials with specific supply chains, but actually, you know, it might be inappropriate to use a specific EPD early in the design process. Maybe you need the industry average EPD. Maybe you need generic data describing the range of possibilities. Sometimes you haven't really designed the assemblies yet. You don't know what's going to go into that wall, but you still need to figure out if it's the exterior assembly or the structure, right? That's going to really drive emissions under different scenarios. So we try to think about this more holistically, which means we have to have a subtler understanding about the data that goes in to inform these decisions. And I'll walk through sort of like that same kind of sequence I had earlier, but try to fill in some of these data sources. Always at each of these steps, we're looking at two things: material quantities and building process data on one side, and the other one, the background impact data. So early on, when you're understanding hotspots and setting goals, the material quantities and process data is predicted quantities. I'm speaking at a panel actually at a conference coming up about AI and machine learning. We use small models to make meaningful predictions of building quantities. And it's like a really, I think, exciting technical thing that we're really engaged in. But the goal is that our users don't have to think actually about AI and ML. They just get to understand that we're making meaningful predictions, right, of what goes into a building at the very earliest stage. And we're using typical regionally appropriate data for materials assemblies, usually describing a range of possibilities, nothing specific yet. As the building evolves, okay, we're moving into assembly estimates, more generic process data, using some specific EPDs where that's available or meaningful, and additionally typical data. As the resolution starts to evolve and maybe we're making more specific decisions, we've gotten the big pieces in place, detailed quantities from BIM, some more modeled process data, and we're really starting to fold in EPDs at this stage to target products, get them into specs, and then filling gaps in the data with baseline or generic data as appropriate. And then it really is only by the time we're starting to procure materials and we're in the construction process that we're trying to use EPDs everywhere possible, because at that point it's meaningful to specify a certain EPD because we know that it's going to be that product and not another product. And we're using as-built quantities and measured process data everywhere that it's meaningful to do so. Now, obviously, we're building these, whole life carbon assessments on top of a very uneven data ecosystem. EPDs are not available for every product. Process data, for things like construction processes, is not available or as often collected as we would like it to be. And one thing, sort of a sneak peek of where we're heading on the back end, is trying to understand how these different sorts of data and the uncertainty related to them affect, they'll say like the range over which these estimates function. So trying to not only manage this data across the process, but managing the uncertainty and inherent in this data across the design process. What designers need to know, the feedback we get, is they're trying to make decisions between, say, scenario A and scenario B. Should it be mass timber? Should it be steel? Should we use a brick rain screen, or should we use, what was the joke earlier? It's a ceramic rain screen. I'm gonna get that exactly right. But with these sorts of like decisions that people are trying to make, relatively less, and that means there's uncertainty about the decision. If you're using an EPD, there's relatively less uncertainty for that product-specific EPD than there is for a generic data point, or a data point that you had to pull from another country to fill the gap. And this management of uncertainty across the design process is, for us, something really essential to provide at the building scale, because it ensures that when people are making decisions or comparing scenarios, that they understand that when they claim a reduction, of one scenario against another, that it's actually significant, and it's not just coming out in the uncertainty, right, between two options. Our goal as we move further forward is to manage uncertainty across the project delivery process, to collect the data related to quantities and processes, and allow that to be sort of a live understanding of where uncertainty lives and how people manage that, because this not only helps understand the meaningful decarbonization choices, but also helps, in a larger sense, just de-risk the project delivery process. Where do you know more? Where do you know less? And how does that inform decisions about design, about decarbonization, and about project delivery that you're making at every stage? So we're really excited to be part of this ecosystem, and to layer sort of in this stack between the demand from the built environment and the material supply, coming from upstream, to really help knit this together. We haven't been around for so long so far as C-Scale, but as we're growing, we're looking forward to growing with the other folks on this call, towards a stronger and healthier data ecosystem overall. So thank you all so much. And with this, I think we could start. There's a bunch of questions that have rolled in. If there's other things you're thinking about, just put them through in the chat. and we can get into a more open discussion, maybe for the next 5 to 10 minutes. But thank you all for sticking around to the end. So I can start sort of kicking through some questions for folks on the call. I want to get to, you sort of, I think, talked about this, Ben, the specific question about the wood being cost competitive with conventional. I'd actually like to ask a similar question to Alex. When you're doing EPDs for manufacturers, how do they think about sort of the potential to either, capture green premium on a material is one way to like make good on the EPD, or on the flip side, this other kind of pricing pressure where they're asked to be cost competitive with conventional products that don't have an EPD. In your conversations with the manufacturers, how is that being balanced?
Yeah, obviously it's always an easier and a more exciting sell when they can claim a premium. And so I think one of the things that manufacturers have been doing is helping the AEC community connect how using materials with a lower embodied carbon can help them accomplish different goals. So for example, there are LEED credits that come from the embodied carbon with materials. And if you can demonstrate that by using a certain type of material, you're going to make it easier to accomplish those credits, that actually is a way that we've seen, particularly within the concrete space, but not exclusively, how manufacturers have been able to kind of claim a bit of a premium, saying, hey, we're already prepared to help you meet these objectives that you have for a building. When it comes to cost parity, I think this is one of the things where I've been really interested in what the team's doing at Cambium, because sometimes you can see how reducing the environmental impact of a product can go hand in hand with also reducing the cost of producing that, particularly when it comes to reducing transportation distances or reducing the amount of energy that's required to prepare a material for consumption within a product, or the opportunity to use waste materials. So those are some of the things that we're also helping with as well. Is how can you identify ways to reduce the footprint of your own operations or of the supply chain that you're working with, that can both accomplish your cost goals as well as reduce your environmental footprint.
That's great.
Yeah. Ben, I'm curious, like, I know I'm always, I already asked you some of that earlier, but I think that, we are just kind of trying to empower people with data. I'm curious, like, how more, I guess, to the extent that like there are clearer examples, or I'm curious for examples on like how people are taking like making actionable decisions or doing things to really actually drive this change, going from like kind of the theory or the models to the actual practice of like what's getting built, what's getting deployed. Curious to learn.
Yeah, no, it makes a ton of sense. I think that the biggest thing that we are trying to drive with scaling the adoption of carbon smart wood, and then ultimately expanding into sourcing other sustainable materials and being able to do that at scale with that, data credibility, with the focus on better experience and better price. I mean, I think that the better experience can't be like understated here, in the sense that like the actual sourcing of materials is pretty convoluted, both from sort of the top level at the buildings level, but then also particularly as you get down, into the sort of like wholesaler, the distributor level, within our space, actual sawmill level. Like there's all of these points in the process where like right now somebody is calling somebody and you're on a 50 email long thread and details are getting lost and takeoffs are really complicated. There's all of these moments for more simplicity, more clarity. And when you get more of that right, again, to a sort of general point here is, if you can be more efficient, if you can be more clear, and if you can provide a better experience at each of those steps, then I think you start to add in, the sort of additional value that really drives decision-making, which ultimately, again, is clearer, transparent, carbon use, and then also price in a big way. Jack, I was curious, sort of pseudo similar, but particularly from C-Scale's perspective, obviously you all are doing amazing work, providing more clarity on data throughout the process. Is there anything that you see particularly effective for the people using that data? Like, who are your best champions? How do they translate that to actually drive impact within their organizations? What is sort of the best practice there?
Yeah, I love that. And I'm going to give a brief answer and then pass it over to Rebecca, because I really feel like Rebecca is one of these people actually at OPN doing that championing. It's been interesting for us, my co-founder Brad and myself, moving out of practice into this role as a software platform, where we've sort of we're a little further from the grit, right? Of how projects come together and are delivered. And it is our kind of honor and privilege every day to support sustainability professionals and champions across firms to help them do their best work. We work with OPN, we work with lots of firms. And the question we ask everyone is what's it going to take to go from 0 to 1 on every project that crosses the board? And we've gotten to, 100% of projects doing some sort of carbon assessment with a 20-person affordable housing firm and a 2,000-person multidiscipline firm. And this is what we are looking to scale. And we don't do this ourselves. We do this by empowering others to work across their firm. But maybe Rebecca, do you want to give some thoughts on just how this works in practice? And then I think we can use that as a nice kind of closing statement for the webinar.
Yes, sure. We're trying to scale this up on all of our projects, but definitely need to start somewhere. So in terms of larger building analysis, we're focusing on projects that are in design right now that we can make a difference on right now, not looking back retroactively at projects that are further into design. And then on the, more granular product side, we've been trying to do a deeper dive into reviewing our baseline specifications and making sure that some of those products that are going to be used across our projects are better options, both from an embodied carbon standpoint and a material health standpoint. And to be able to be comfortable having that be a baseline expectation across projects, there is some reassurance needed that it's not going to come at a large cost premium. So that's why we are trying to understand what is the data availability across product types, and know that we can meet these criteria with multiple options in the market today.
Thank you, Rebecca. And thank you, Alex. And thank you, Ben. I see people starting to drop off as they probably have to go to the next call after this, but really excited about the turnout today and the contributions of all the panelists. Thank you all for being here. And, we'll see you around as we're all working towards a decarbonized built environment. Cheers.
Thanks, all.
Thank you.